My name is Bailey Chapin, and this is my Physics 2211 Lab 4 on oscillations. Let's get into the introduction. The goals and purpose of this experiment is to compare the predicted motion using GlowScript with the observed motion using the tracker program of a mass attached to a spring. We are then going to plot the energy changes within the system for the predicted motion, which would be the change in kinetic, gravitational potential, spring potential, and total energy. The findings of this experiment show that the predicted and observed motion are similar on both axes, even more so on the x-axis, and the total change in energy is equal to 0. The first key concept of this experiment is based on Newton's second law, which states that the net force of an object is the change in momentum over time. This law can be further rearranged into the velocity update formula. The position update formula can also be derived from Newton's second law. The next key concept is the energy principle, which states that the change in the energy of a system, delta E, is equal to the work done on the system by the surroundings plus the exchange of thermal energy between the system and the surroundings, which is equal to Q. And you can see that equation listed on the slide. The system must be defined when dealing with energy because different objects mean different energies and work. The energies that we will be using in this lab are kinetic energy, which is equal to 1/2 times the mass times the velocity squared, the gravitational potential energy, which is equal to the mass times the gravity near the surface of the Earth times the change in height, and the spring potential energy is equal to 1/2 the spring constant times the displacement. The system for this experiment is the Earth, the spring, and the mass, and the surroundings are none. Because nothing in the surroundings is doing work, W of the surrounding, or work of the surroundings, is equal to 0, and also it should be noted that Q is equal to 0. The change in energy of the system is then therefore equal to 0 based on the equation shown. It should also be noted that F net is also equal to 0, which is, in F net here is the gravitational force plus the spring force. The video of the tracker analysis. The tracker analysis gives us 0.095 seconds per frame. We know that the object mass is 0.402 kilograms, and the initial conditions are that the start time is equal to 0 seconds. The initial position and initial velocity are listed here as well. Here are the initial conditions for the computational model based on the conditions from the previous slide. The mass was given from the pre-lecture videos, and the initial position and initial velocity, as well as delta t, were found from the tracker analysis. Here are the constants from the computational code. The gravitational force near Earth's surface is equal to 9.8, and the spring constant and relaxed length of the spring were found using the equations to the right. The time period of oscillation was used to find k, or the spring constant, and F net was used to find the relaxed length of the spring. Physics equations from this lab in code. The first is the code for the distance from the relaxed length of the spring. The second is the other energies, which are kinetic, potential, spring, and gravitational energies, and the change in energy of the system, which is equal to 0. The final equations in the code were the F net, gravitational force, spring force, and velocity and position update formula, which are shown on the bottom. Here is the code for the iteration of the computational model, as well as the code for the comparison between the experimental and the computational model. After the code was run for a fairly long period of time, the results were this diagram along with 3 graphs. The first graph on the left shows the change in all of the energies versus time. The other 2 graphs show the x and y positions as a function of time when comparing the experimental and computational model. The experimental model is in red and the computational model is in blue. Now let's discuss. For the change in energy versus time graph, the change in gravitational potential energy is in red and the change in spring potential energy is in green, and they look to oscillate, meaning that they are opposite in sign. The change in kinetic energy, which is in blue, also oscillates slightly, but with lesser magnitude compared to the spring potential and the gravitational potential energies. As for the position versus time graphs, the computational model proves very accurate in predicting the motion in the x direction. The computational model is not as accurate in predicting motion in the y direction. Some possible sources of error is that we only accounted for gravitational and spring forces and no drag forces. We did not account for all other energies, including thermal, and there also could have been discrepancies with the tracker analysis. For the first question of what does it mean, is the energy principle satisfied? The answer to this is yes. The sum of all 3 changes in spring potential, gravitational potential, and kinetic energy equals 0, and this is represented by the orange line in the graph. The potential spring and gravitational energies are close in magnitude and opposite in sign, and any differences are accounted for by the lesser magnitude of the kinetic energy. All of this results in the change in energy of the system being equal to 0. Second, what does it mean question, we're going to look at the oscillation periods from the x and y positions from tracker. To calculate these, we're going to calculate the time between either 2 crests or 2 troughs. The average oscillation period was determined by finding the average of 3 cycles or the sum of 3 periods. The average oscillation period of X was found to be 1.677 seconds, and the average oscillation period of Y was found to be 1.520 seconds, and the difference was 0.157 seconds. The difference can have effects on the spring constant, spring force, and spring potential energy, as shown in the equations previously in this presentation. The difference of the periods themselves are also caused by possible errors of the tracking software and drag forces which were not accounted for. Thank you.